Hey, welcome to our physics class. Today class we're going to be dealing with waves. It's one of the most requested video in our DM and our comment section. So today's video we're going to now treat waves. But now this video is going to be introduction to waves, and from this video we're going to start dropping episodes from other waves topic. Now in today's video we're going to look at the waves. Now a wave is a disturbance that transfers energy from one point to another without permanent movement of particles of the medium. Now, we are going to, before we understand this, there are some scenarios I want you to understand. Now, a wave actually moves in a medium. Moves in a what? A medium. Some doesn't also mean a medium. And a medium can be air, which is in form of gases. In form of gases. The medium can be solid. The medium can be liquid. And the medium can be a space. A wave moves in gases, which is in form of air, solid, liquid, or what, or space. Now, what's a medium? A medium is a part that something moves. And wave is what we call a disturbance. So this disturbance happens with either gases or air. It happens in solid, it happens in liquid, it happens in space. When someone talks, as I'm talking now, I'm introducing my voice to the air. I'm disturbing the air. Now, if the air has this particular distance before and I now talk, what do you think will happen? This air will go like this because my voice have actually what distract how the air is. It has disturbed this particular air. Now, a solid, when I hit a solid, have a solid, you hit it, boom. That particular hitting you did, you have actually done what? You have actually disturbed that solid. Now, liquid. Once I touch this thing, water, all those sound, all those things, and the movement of the water, I've actually disturbed that water. Now, space. You see transmitters, even from TV, you just stay in your house, you see this thing, you are watching movies, you are watching streaming movies. All those things was actually, there was something that was projected through space to the house. There was a disturbance before that arrived. Now, a wave itself is a disturbance that transfers energy. Now, pay attention to this. It's a disturbance that transfers energy. It is the energy of the wave that actually does what? That actually causes the disturbance. The energy from the wave. Energy from the wave. It's the energy from the wave, the energy from my voice. Those are the things that distort the air. The energy from my voice. Now, it is the energy from that particular thing you hit. Boom. That is why the more you hit it, the more what energy is going to produce. And which type of energy will it produce that particular time? Sound energy. So if you hit it small, boom, you see that the disturbance is small. And the energy that is going to be produced is going to be what? Is going to be very small. Now, the wave itself deals with what? The disturbance that has to do with transfer of energy from one point of a medium to another. From one point of a medium to another. So if a medium is like this and it transfers energy from here to this particular point. Now let me give you one scenario so that you can see how waves move. Now if you see people watching ball in the stadium, you see them sometimes, you see them celebrating, doing her like this. Sometimes it be like this, you see the energy is moving from like this to like this. But those people itself, they are not being transferred. But what do you think? There is transfer of energy. They just practice it and be like this. Then the next person just follows suit. The next person follows suit. The next person follows suit. Now, what happens there is that there is what? The transfer of what? Energy. Now, let's continue our definition. The wave is a disturbance. The disturbance has to do with transfer of what? Energy from one point to another without permanent transfer of particles. Without permanent, sometimes they say that without permanent displacement of the particles or without permanent transfer of what? or without permanently displacing the particle. What do we mean by this? Everything we are going to do it here has particles. Everything I'm going to do it here have particles, which means that is what is matter. Most of the things we are going to do here has particles. Now, if they have particles that made up them, because it's particles that make up matter, and there's a disturbance that happen in that particular thing. For that disturbance to happen, it must distort some of the parts of the particles. But immediately the energy is gone from there, the particles comes back to how it was before. Now, listen to what I said. I said that the matter itself, the object that the wave comes to disturb, has particles. Now, for the disturbance to happen, the particles must what? Maybe they must touch the particles. Just look at someone that is running, and just hit you, bam, small, and you just after a while, now get yourself back. There's a disturbance, but the particles that made you did not travel with that energy that the person hits you, because it's the energy that makes it with the person to hit you. Now, the particles of you did not actually follow the person. After a while, you return back to how it is. That is how waves work. The wave has to do with disturbance that happen in a medium, and not only happen in a medium, it transfers what? Energy from one point of that medium to another. And at the end of the day, there is no permanently displacement of the particles. The particles will just disturbed. The particles does not move. Now, let me give another scenario. You see a water bottle, you just throw a water bottle to an ocean. And the ocean is performing waves. You see it going up, going down. You see the water bottle going up and going down in the ocean, going up and going down. But when the wave settles, what do you think will happen to that particular water bottle? The water bottle will come down and settle with the distance and just be floating on the water. Now, it was why what made it to be flowing up and down is because of energy. That's the major thing that made it to be flowing up, flowing down. That is the major thing. By the end of the day, when the water calmed down, the particles now remain how it was. So now remember how I said. Now let's now go back to the definition. A wave is a disturbance that transfers energy from one point to another, one point of that medium to another, without permanent movement of particles of that medium. There is no particle, as in there is no permanent displacement of that particular distance. Now let's go to the classification of waves. Before we go to the classification of waves, now it's the answer scenario. Some people can talk about wave motion, wave motion, wave motion. Now when we talk about wave motion, wave motion is the process of disturbance. So that when you are asked what is wave motion, you should know the difference between wave motion and normal wave. The wave motion is what is the movement of this disturbance. Motion has to do with what? Movement. Movement of this disturbance, that is what wave motion is. While wave is the disturbance itself, wave motion is the what? Movement of waves. So you should have it in mind in case if you see something like this. Now, another thing again, you may see something like particles, and wave. Someone may ask you, or in your exams, they may ask you, what is the major differences between particles and wave? Major differences between particles and wave. Now, when we talk about particles, we're talking about something that make up a matter. When we talk about wave, wave is a disturbance. So the major first, what is it called? The major first differences between particle and wave is that a particle is what make up a matter. Is a tiny piece that make up a matter. Now, why a wave is a what? A disturbance. A wave is a disturbance. Now, a wave can a wave, when it comes to the motion first, a wave can undergo something called oscillatory motion, that's to and fro movement. A wave can also undergo a linear motion. Now, But when it comes to particles can undergo every forms of motion. Now, a wave can be diffracted. The particles cannot be diffracted. What does diffraction mean? Diffraction has to do with bending down of waves. Bending of waves. Let me give you an example. I like working with examples so you can understand the scenario. You see something like a tree in the middle of water. You see a tree in the middle of water, and you see that when water is flowing there beside that, you see them bending down to avoid those obstacles. That's diffraction. Bending down to avoid that what obstacles. Or even when you flash torch on a side that is corner like this, is that what happens is that the water tries to do what? Bend to do what? To actually enter that side. That is a form of what? That's one of the distinct differences of wave and particles. Wave diffracts, particles does not. Once the particle reaches there, it stops there, it does not diffract. You understand? It does not do what? Diffract, but the wave itself what? Diffracts. These are the major, what is it called? Major differences between particles and waves.